Our video today is going to take us through graphing parallel lines and perpendicular lines. So we're going to be doing two lines on one graph. So there are some tricks to this in order for you to remember which ones are which. Equations are the same. All that stuff's going to be back for this section. So let's get started. So a little bit of review. So for the first one, we may have to find our slope. And this little slope formula that we use is the y2 minus y1, x2 minus x1, or vice versa. It depends on which y you choose, which sets your x at the bottom. Your slope-intercept form, that is your y equals mx plus b, where m is your slope and b is your y-intercept. And we're going to be working on finding this part of the equation again for some of this. So for parallel lines, we have two non-vertical lines, same plane in the same area, have the same slope. They are parallel. So the key word here is same slope for what we're looking for. They will have different y-intercepts. So when you're looking at two equations and they're asking you, are they parallel, the first thing that you look for is, and really the only thing you look for is the same slope for that. That will give you whether they are parallel or not. So a couple examples of some parallel lines: railroad tracks. They will go on forever. They will never meet. And then we have a night shot of the New York City skyline with the two remembering lights from the World Trade Towers. Those again are parallel. They would never meet as they go up into the sky. So some examples for this: if we are given line 1 and line 2, first thing that we want to look for is our slope. If they are identical and we graph them out, so if we graph out line number 1, this is what we would have. So our b is our y-intercept, our slope is 2, so we go up 2 and right 1. That would make our line. If we graph our second line, again we start at -3, different y-intercept. We go up 2 over 1 to the right, and that would give us our line 2. And you notice that they are parallel and they would never meet in that graph plane that you put on the paper. So these are two parallel lines because they have the same slope, and no matter how far you continue the lines, they will never cross each other. So those are some key things that you want to remember as you go through this. All right, so some equations in regards to, are these parallel or not? So if I give you two equations, first thing again, look for the slope. Y-intercepts aren't important in this case except in graphing. So our second equation set, if we take a look at it again, looking for our slope, and our third one as our example. So if you're looking at it, line number 1, or the set of line equations for number 1, they are parallel. They have identical slopes. Lines 2 and 3 for the two graphs are not parallel. They are not the same. Yes, this looks the same, but they're not identical. This is negative, this is positive, so they go in different directions. So how do you write an equation? So we're going to, again, piggyback off of stuff that we've done in the past for this. So here are your steps that you want to take a look at in what we're given. So the question is going to be written: write an equation of the line that passes through the point -3, -5, and is parallel to the line y equals 3x minus 1. So we want to write the equation of the line that passes through this point. So we want to graph this point if we want to, but we want to know that it's parallel to this line. So this is the line that we're going to work off of being parallel. This is the point of this new line that we're going to graph if we were asked to graph it. All we're asked to do is make an equation. Remember one thing about parallel lines: they have the same slope. So we know what the slope is of the first line, and that's 3. Well, to find the new y-intercept, we know the slope of this line and we have the points of these. So we're going to insert and find b for what we've given. So y is -5, b is negative, or x is -3. Our slope is 3. So if we reorganize this equation, we're going to find that our b is 4. So as you look through the solving of that, you can see where this comes out to be 4. So when we put this back together, when we write the equation, remember that the slopes are the same. So our y equals 3x now plus 4, because that's the new y-intercept that we found. So our slopes are identical. It's the y-intercepts that are different. So this would be the equation of the line that we're looking for. So what I would like you to do is try these examples and bring these as a part of your notes. So your first equation is, and then your second example or question is. So bring those into class with the equations written and see how well you do with the examples. Okay. So let's go into perpendicular lines. Perpendicular lines are lines that now have negative reciprocals, and they are in the same plane. The slopes are negative reciprocals. So when you're looking at parallel lines, the big thing here again is negative reciprocals. When they intersect, they have to form a right angle. So when you do these, make sure that you are using a ruler to make the line straight so that you can see the 90-degree intersection. So some examples of perpendicular are where the sidewalks meet here, cracks, telephone pole and the bracket, and then we have our railroad sign. So this is our 90-degree here. So again, key things on perpendicular is you have a negative reciprocal for your slope. So if I give you two examples of this one, another couple examples, and our last two. So if we look through example number 1, these two are perpendicular because they have a negative reciprocal. Number 2 is not perpendicular. They would be parallel because they have the same slope. And 3 is perpendicular because they have the negative reciprocal, and the coefficient here being 1. So that's why this would be still 1. 1 over 1 is still 1 over 1, but it's negative. So that's the big thing. And then we have the final one, which is perpendicular because you have, again, the reciprocal and it's the negative of it. So negative of a negative is a positive, so that also works as an opposite or the negative reciprocal of that. So when we determine whether the lines are perpendicular or parallel, we're looking at slopes. So again, parallel, the slope is the same. Perpendicular, it's the negative reciprocal. So if I give you these three equations, A, y equals 5x minus 3, B, x plus 5y equals 2, C, negative 10y minus 2x equals 9, what you have to do first is you have to put them into slope-intercept form. So when we look at this and how we work this is you reorganize these into slope-intercept form. Our key focus is going to be our slope. So when we ask the question which are parallel, which are perpendicular, we come up with, in the parallel sense, line B and C are parallel because we have the same slope. For perpendicular, line A and B are perpendicular because they are negative reciprocals. And so is A and C. A and C have a negative reciprocal for the slope. So again, that's the key parts of what we're looking for in this section. We're not changing anything except changing them into slope-intercept form, but everything else we're working the same as what we've done in the past. So a couple examples. So write an equation of the line that passes through 4, -5 and is perpendicular to the line. Okay, so we know the slope here in this part is 2. Well, we know that because the slope of perpendicular lines are negative reciprocals, we would reciprocal 2 over 1 and make it negative, so that would give us -1/2. So again, we'd have to find B. So when we do that, we put on our points, x and y, and we put in our new slope, which is the reciprocal of the one given, so a -1/2. So when we reciprocal that and we multiply it, we end up with -2. And we solve it for b, which would give us -3. Once we do that, we know what our slope is. That's -1/2. And now we know what b is, -3. So our new equation comes out to be -1/2 x minus 3. So it's just keeping things straight and in order of which lines are you working with, parallel, perpendicular, to get you those numbers. So these examples, again, I want you to bring into class as a part of your notes. So here's your first example, is line A perpendicular to line B. And then our last one, write an equation of the line that passes through 4, 3 and is perpendicular to line y equals 4x minus 7. So again, just keeping things straight will make this a lot easier as you go through it. What is a perpendicular line? What is a parallel line? And the major focus is we're looking at the slope for what we're dealing with. Our y-intercept b we'll have to find in some cases, like example number 5. But other than that, everything else is pretty straightforward in what you're being asked to do here. So good luck with that. Bring your notes, and good luck on your assignments.